Hello everyone, welcome to Math 1151 Midterm 3 Review Problems. So firstly we look at this problem on the optimization. So we have a piece of wire of length 100 in total, and it is cut into two different pieces, and one piece is used to make a circle and the other part is to make a square. So we want to know where we should cut the wire to maximize the combined area of the circle and the square, and where we should cut the wire to minimize the combined area of the circle and the square. Okay, so we assume that x is used to form the circle, and then 100 minus x is used for the square. Okay, alright, now because the wire x is used for circle, that means the circumferences of the circle is x. But we know that the circumference of the circle is given by 2 times pi times the radius r. So we can conclude that x is equal to 2 pi times r. And from here, we can solve for r. The radius of the circle is given by x divided by 2 pi. Okay? So after we know this radius of this circle, we can find the area of the square of the circle is equal to pi times r squared, but our r here is equal to x over 2 pi. So the area of the circle is given by pi times x over 2 pi squared. And if we simplify this, we have x squared over 4 pi. Okay, so this is the area of the circle. And then, because we use the 100 minus x for the square, and then that means the circumference of the square is 100 minus x. But we know that the circumference of a square is given by 4 times d, and d is the length of each side. So that means we have a relation between x and d, which is given by 100 minus x equal to 4d, and d is equal to 100 minus x over 4. Okay, then the area of the square is given by the length of the side square, that is d squared, and here we have d is equal to 100 minus x over 4. That means the area of the square is equal to 100 minus x over 4 square. Okay? So this is the area of the square. Now we have both the area of the circle and the area of the square. We can find the combined area of the circle and the square is given by capital S equal to the sum of the area of the circle and the area of the square, which is x squared over 4 pi plus 100 minus x squared over 16. Okay? And now we want to maximize and minimize the combined area. That is, we want to maximize and minimize the function s. And we can see that this function s is a function of x in terms of x. Okay? So we can take the derivative of s in terms of x. So s prime, and we are going to differentiate this function in terms of x. And we firstly differentiate this first term, which is x squared over 4 pi. The resulting derivative is 2x over 4 pi. So basically it is x over 2 pi. So I'm going to simplify it as x over 2 pi. And then for this second part, we're going to differentiate in terms of x. And then we will have 2 times 100 minus x over 16, and then times -1. Remember the chain rule, okay? And actually we can simplify it, and we will have x over 2 pi for the first term, and then plus x minus 100 over 8. And we're going to set this to be 0. Okay? And then if we actually solve this equation, we will have solve for x, and we will have x is equal to 100 pi over 4 plus pi. And this is about 43.99. Okay? And we already got a critical point for this function, but we have no idea whether this function achieves its maximum or minimum at this given point x. So we're going to use the second derivative test. So if we further differentiate this function s, that is, take the derivative of s prime, we will have s double prime is given by 1 over 2 pi plus 1 over 8, which is always positive. That means when x equal to 11 pi over 4 plus pi, which is about 43.99, we have a minimum. Okay? And if we plug this x equal to 100 pi over 4 plus pi back into the original s function, we will have the minimum of s is equal to s 100 pi over 4 plus pi, and this is equal to 2500 over 4 plus pi. Okay, this is the minimum. But now we still need to find the maximum. And remember, here x represents the length, and that means x can only be between 0 and 100. Okay? So we're going to check the endpoint to find the maximum. So firstly we check the left endpoint, which is 0. If we plug in x equal to 0, and we will have 100 squared over 16, and we will have 625. And next we check the right endpoint, that is when x equal to 100, and we will have this is equal to 2500 over pi. If we simplify it, this is approximately 795.775. And we can see when x is equal to 100, the resulting combined area of the circle and the square is greater than the combined area when x equal to 0. So this will be our maximum. That is when x equal to 100. Basically, that means we're using the entire wire to make the circle instead of the square. Okay, so this is this problem. So the maximum combined area of the circle and the square is equal to 795.775, and the minimum combined area of the circle and the square is equal to 2500 over 4 plus pi. Okay, this is problem.